Hey, how are you guys doing this evening? Hopefully you guys can hear me all well. Hopefully you guys had a good week. It was kind of hectic for me from last week, but I mean, nothing too crazy. I was kind of getting over a cold. The last stream that I did that night, it was just miserable. And yeah, long story short, I don't need to talk about that. But so hopefully you guys are all doing well. I've got some stuff I want to talk about. I've got a little thing I wanted to kind of cover real quick to kind of start out with, and then we'll see if we can't get to some of your guys' questions, okay? I see there's a lot of guys here in the chat. It kind of still blows my mind how many people come into this thing right away, but it's a trip. So, and for those of you, there's probably only a few of you that do live streaming and stuff. YouTube has this new stream screen, whatever, and it's very distracting. I kind of think I need to come up with a new thing where I don't have to stare at it because it shows you numbers and it's kind of whatever. I don't need to pay attention to that because it just distracts you. So I wanted to start by talking about a little problem I ran into today, and I just thought it was a good teaching point, and hopefully you guys get something from this. So I've mentioned this before in my videos and different things, but it's taking an educated guess, okay? That sounds kind of like a scary word, or a scary phrase, I should say. But sometimes you got to do what you got to do when you can't seem to figure out what was going on. And so let me give you an example. So today I got a service call on a package unit, air conditioner not working. It's a small little 5-ton unit. And the complaint was that it wasn't working. So when I arrived, I walked in the door and the manager said, "Oh, no." She said, I just called and canceled the call. And she goes, "You must not have received it yet." And excuse me. So I said, "Yeah, no, I didn't receive it yet. But I'm here, so why don't you tell me what's going on?" And she says, "Okay." She goes, "Well, I'd rather have you check it out since you're here." So she explains to me that her office air conditioner wasn't working. So, okay. So I asked her a few questions. How long has it been doing this? Was it all weekend or was it just today? She goes, "It was just today." She goes, "Normally when I come into my office at 6 in the morning, she goes, it's cold in here." And she goes, I noticed about 10 a.m. it was still warm in here. And she goes, "It wasn't getting cool at all." And she goes, "In fact, it was about 80 degrees in my office." So she said she went over to the thermostat and she didn't quite remember what it said, but she kind of pushed a few buttons and then nothing really happened. So she figured, I was already on my way, so whatever. Well, in the meantime, then all of a sudden the air conditioner started working. And then I walked in the door. And she said, just go ahead and check it out. So I went up onto the roof, immediately jumped on the roof. The unit was running, but you can tell that my return air temperature was about 82 degrees. So you can tell that it had just turned on, okay? Because had it been running for a little while, the potential of the return air to be more or less like 76, 75, but the fact that it was still 82 degrees and that was the temperature in the office, to me, told me that it just came on. So again, you kind of have to, I'm working my way through this, trying to pay attention to everything and use my senses. So went ahead and just pulled off a couple panels. I didn't shut anything off. I pulled off a couple panels, amped out the condenser fan motor, which is like a common thing. If the condenser fan motor failed, it might have got off on high head pressure. Who knows? So amped out the condenser fan motor, inspected the electrical. I did not see a need to put on service gauges at this point. The supply air temperature was about 22 degrees below the return air temp, which, not too bad. And I have history with this particular unit. I had just actually done a video on it where it's a small little 5-ton and we changed a compressor. That was the one where I had the apprentice brazing in the liquid line dryer. So anyways, couldn't find anything wrong, right off the bat. So then I went downstairs and started talking to the manager. And I went to the thermostat again, and I noticed that in front of the thermostat, they stacked a crap ton of jackets. And there was purses and everything all leaning on the thermostat. So I had to move all that stuff to get to it. And then I'm just looking at it, and I noticed that this is an older Venstar thermostat. Not really a fan of them. They replaced the old school Carrier thermostats. Anyway, so noticed that the program wasn't turned on. It was actually turned into auto mode, which means that it's going to run at whatever temperature it's at and never shut off until someone physically goes and turns it off, okay? So I brought that to her attention. I said, it's in auto mode right now. She goes, "Well, I changed that." She goes, "When I was playing with it, I was just kind of moving through the cycles, and I put it into auto mode." She goes, "And then it turned on." So at this point, I went through everything, and my diagnosis in my head before I talked to her was either the thermostat was turned off or the thermostat is going bad, because everything else seems to check out okay. But unfortunately, I'm not seeing whatever the problem was in front of, what she was seeing. It was working when I got there. It's one of those ghost problems, right? So the way that I approached this was I just went down and logically explained everything to her. Look, this is what I found. I really don't think there's anything wrong with the rooftop unit. Everything seems to be fine. And here's my assumptions. I'm going to make an educated guess, and I'm going to tell you that either we have a bad thermostat or it was simply turned off. And I basically, at that point, put the decision-making process into her hands, okay, and let her make the decision. I said, look, we've changed 3 of the 6 thermostats in the last couple years here. I said, so, it's logical to think that this thermostat's going bad, but it's working fine right now. So what do you want to do? And I let her be part of the decision-making process, okay, in that situation. Now, what I did by doing that was I put some of the responsibility in her lap, okay? I gave her the facts, let her know what was going on, and then let her decide that, hey, you know what, I want to wait and see if it happens again, okay? Now, in the meantime, what I went ahead and did was I went ahead and I checked the programs on all their thermostats, set the times, verified, and then went ahead and locked them all. So that way nobody can turn them off anymore accidentally, potentially, okay? So now if I have to go back again and the thermostat is still locked and I find it in the off position, then it's logical to think that maybe the thermostat's going bad. So, sometimes, in my opinion, we have to make these educated guesses, and they might lead to problems, they might not. But if I can't find anything wrong, I'm not going to guess that, hey, it's got, this going on or this going on. I mean, the only thing that could lead me to it was that the thermostat was something to do with the problem, whether it was turned off or whether it was simply going bad, So, sometimes we have to do those. In a situation where you're not capable of making those decisions, I'd highly suggest you lean on your management, whoever your supervisor is or something like that. But, in this situation, I just basically put it in her hands and she decided that she wanted to wait. So, and I very politely documented everything in the invoice that the manager declined changing the thermostat and, that she just wants to wait and see what happens. Okay. So then that takes the liability out of my lap if there's another problem again tonight. And it was nothing rude, nothing hostile, the conversation that we had. It was just a very nice conversation. She totally agreed, like, oh, I understand. And I explained to her. I wrote this all in the invoice, and she's like, okay, cool. I really appreciate it, So just one of those things. Hopefully that helps you. Maybe you guys in the chat, do you guys ever have to do that kind of stuff? Do you ever have to make educated guesses and, decide that kind of stuff? I run into having to make those decisions quite often where you have to make an educated guess, where you just look at everything, knock things off your list. Okay, it's not this, it's not this. It logically doesn't seem like this, and move your way down the line. So see what you guys have to say in the chat here. Let's see. Right on. There's quite a few people in here. One thing I do want to go ahead and get off my list of things to do right here is I mentioned it on the last stream that Sporlan has their Sporlan 85 promotion. What they want you to do is take a picture of any of the older Sporlan memorabilia, an older Sporlan component, a brochure, something sitting at a supply house, and put it on social media, on Twitter or on Facebook with the hashtag Sporlan85, and you'll be entered into a drawing to win some beer mugs. This is actually one of the mugs right here. They actually just sent these to me today. Sporlan 85. It's just a nice glass. It's got some blue writing on it. Really cool little glass. Of course, this glass has apple juice in it, guys. Okay. Yeah, you get entered into a drawing to win one of these. So it's a really easy little thing. All you got to do is tag Sporlan with the hashtag Sporlan 85. So I highly suggest you guys try it and see if you guys can't win some of those glasses. I got a couple more sitting right up there. So, all right. Yeah, I see, Justin. You said process of elimination. Exactly, dude. Sometimes you got to do it. You just got to kind of go through the list there and see what you can find. So hello to everybody that's saying hi. How you guys doing today? There's quite a few people in here. I can't really say hey to everybody, but you all get what I'm saying here. So, let's go through my list. Do me a favor, just like Justin, my moderator, had said earlier, if you guys have questions, please put them in caps lock so that way we can try to make sure we get to them and we address everything. So let's see. All right. I don't see any questions as of yet, so I'm going to go ahead and go to my list. For those of you that sent me emails for the shirts, I sent out a bunch of shirts, and hopefully you guys got them. The people that I didn't respond, I sent emails once I shipped the shirt. So if you didn't get an email back from me yet, I'm just simply out of shirts. So I'm working on placing another order. and then we'll figure out a better distribution method, because the permanent method of distributing them is not going to be me sending them out the way that I did. But yeah, I should get another order in soon, and I haven't placed it yet, but I kind of got to get a count, and then we'll work on getting some more shirts for you guys. So let me turn on my fan because I'm kind of getting hot over here. All right. There we go. And let's go ahead and get to our list. Okay. That's funny. So you watch my videos, but you have no idea what I'm talking about half the time. Right on, bud. You know, it's interesting. I get a few emails from people that don't know anything about the industry, but yet still watch these videos. It's kind of funny. So kind of a trip. Yes, I do. I own my business. It's a partnership. I work with my dad. Him and I are partnered together, and we run this together. We're a small refrigeration company here in Southern California. We've just got a couple service trucks out there, guys. Nothing crazy. Myself, my truck, and four trucks traveling all together. So 4 employees. Yeah, so it's going good so far. We're just a small little company. We try not to get too busy. We try not to go too crazy. So, all right. How do I feel about easy seal on RTUs with leak detection? That's a great question to start this off. Okay. I'm not judging you guys if you do it. My personal preference is to not use any additives in my air conditioning or refrigeration systems that don't pretty much come in the system, okay? So I'm not a fan of like the leak sealants, the dyes and different things like that. I'm not going to lie and say I've never used them, because I have. I've used a leak sealant on 2 occasions where the customer specifically asked for us to put a leak sealant in there. I'm going to tell you that both of the times, I never saw any great results from those leak sealants. They were both 2 different types of leak sealants. And as far as dyes go, I have used dyes 2 or 3 times. Not a fan of them. It was something else. Again, last ditch effort. The customer wanted us to do it, and we did. And, you know, that's what we put in there. But, personally not a fan of the dyes, just not something that I want to use, or the leak sealants. Okay. Now, you know, I know that there's situations that may call for it. You know, you've got a line set you can't get to or something like that, but I've read a lot of great information. I've listened to some interesting podcasts, especially some with Mr. John Pastorello from Refrigeration Technologies, where he's basically talked about what's in the dyes. And, you know, I understand he's just a person and I'm listening to what he's saying, but it's very interesting. What he says sounds very believable about the additives and different things. And it's just not really something that I choose to put into the systems that I'm working on. So my personal preference is just to stick to, you know, fixing the leak. You know, if you can't find the leak, pump the system up with nitrogen with a tracer gas of whatever the refrigerant is, and look for the leak that way. Keep adding gas. You know, the leak's going to get bigger and bigger over time. So just keep adding nitrogen, building up the pressure, being safe. Not, you know, you don't ever want to exceed the operating limits of the coil or anything like that. But knock on wood, cross my fingers, I've always been able to find the leaks that I've been looking for. So what books do I recommend to go to and take the C38 test? You want to start your own company? Aldo, I have to tell you, honestly, I don't know of a book to take the C38 test. I honestly don't have my contractor's license. So I wouldn't know, but I'm sure there's tons of study materials out there for your contractor's license. So, you know, have I noticed capacity loss in walk-in coolers with drop-in refrigerants? You know, I really haven't seen a big problem there, Steve, with the drop-in refrigerants. I've used a few different drop-ins over the years. Where I saw problems was not so much in the capacity per se, but it was in okay, so background. I came up in the trade in the mid 90s, so we were using a lot of the R12 drop-ins, R409A, and we were using the 502 drop-ins, R408A, Hot Shot, different ones like that. Okay, so one of the problems that we ran into at that time was the refrigerant manufacturers were giving the refrigerants to the supply houses, and the supply houses were giving us very vague information. The internet wasn't as popular and as easy to use at the time, so we kind of had to rely on what the supply houses told us. A lot of the systems, when we were going into the 400 series refrigerants, 409A and 408A, they ran higher head pressure, basically, okay? And they were replacing R12 and R502. When they were replacing R12, that was a bigger issue. The 409A ran a little bit higher on the head pressure. You ran the 160s, 170 range, when the R12 refrigerant was running, you know, in the below 150 range. So But it wasn't just the head pressure. What we were finding was it was the density of the refrigerant and all kinds of fancy technical terms. But if you would just drop in R409A on an old R12 system that had a receiver, there wasn't enough capacity or enough storage capacity in the system to hold all the refrigerant needed to run the system properly. The reason why I'm telling you that is we still have the same problems today, okay? When you use a drop-in refrigerant, you have to pay attention to how much you're adding. So they always say to start with like 70 or 80% of the charge, the weight-in charge, and then adjust by superheat and subcooling from there. What you really need to pay attention to when you're working on refrigeration systems is, like, for instance, when you're done, you need to try to pump it down and make sure that the receiver's not overfilled with refrigerant, okay? Be very careful about using the drop-in refrigerants without changing refrigerant oils, and also understand what the term drop-in means, okay? The term drop-in is kind of misleading. It does not mean that you just put the refrigerant in on top of the other refrigerant. You never mix refrigerants, okay? The next thing is even though it's a drop-in refrigerant, you might still have to change the oil. It depends on what the refrigerant is. Even if it says it works okay with the type of oil that your system has, it may not. You need to do some of the research yourself and not just trust what the supply houses tell you, okay? Hopefully that answers your question. So, all right, Thanasis, you're checking, thanks for the super chat, by the way. So you're checking your 240 volt condenser fan motor between line 1 and line 2, and you have resistance, but your ohm meter is beeping. Does that mean that my lines are shorted between L1 and L2? No, not necessarily. Depends on the sensitivity of the continuity tester on your ohm meter. So it doesn't necessarily, just because you're getting an audible tone doesn't necessarily mean that it's shorted. No, not necessarily. So, all right, let's see. I'm going to go ahead and get to my list here. And so a question that I got from about 3 or 4 people between my last 2 videos was, especially my last video where I posted about a walk-in, what was it about? It was about a walk-in freezer. I'm going to refresh my memory here for a sec. Walk-in freezer with the superheat too low. And I mentioned that in that video, that was the one where I adjusted the expansion valve, open and closed, and got it to start, reacting. And I'm putting in a quote basically to replace the expansion valve. But I said at the same time, when I change the expansion valve, I'm going to recommend that they change the thermostat. I'm going to recommend that we change the solenoid valve and the contactor, the TXV, and then add a liquid line dryer and a sight glass. I think that was it. And the question that I got was, why are you going to change those other parts if they're not bad? Again, I'm taking experience and I'm making an educated guess, I guess you could almost say, okay? I've had a high failure rate on those cold pack walk-in evaporator coils with the solenoid valves and the TXVs, especially when they have the Emerson TXVs and solenoid valves. So I'm going to open that system up, and I'm not going to not change that solenoid valve. Plus, I'm going to end up repiping it, so changing the solenoid valve is actually going to make it easier, okay? So, sometimes when you have to think logically when you're in a system, and you have to think, okay, if I'm going to be in here, once I finish this repair, I'm going to own this system, meaning that the customer is going to think I fixed it, and if anything else breaks, they're going to say, hey, what the heck, okay? Not saying that they're justified in that, but I'm going to nip that in the butt. It's a $40 solenoid valve, okay, that I'm going to change while I'm in there making a $1,200 repair, whatever it is. You might as well just go ahead and change that solenoid valve. I'm not one for just changing parts like crazy, but because of the history that I have with those valves failing, because of the fact that I don't like the way that thermostat works. It's a junky thermostat, in my opinion. I have a lot of problems. My quote is just going to be to change all those parts, because I think that's going to be the best bet where I can stand behind that unit and guarantee that it's going to work, okay? Understanding that, other things may break in the future. So, okay, so let's see what else we got. Okay, so do I have to pump down or recover to change the power head of a TXV? Gabriel Brown. Well, if it's a refrigeration system, that is a standard pump down system, okay, and it has a liquid line receiver. Yes, what you can do, you do not have to necessarily recover the refrigerant, okay? So long as it has the right valves, you can pump the refrigerant down and it has enough storage capacity in the receiver. You can basically front seat the king valve on the receiver, and let all the refrigerant keep pumping. So the compressor is going to keep sucking on one side and pushing gas out on the other side, but it's not going to let it leave the receiver. So the discharge gas is just going to keep pumping that refrigerant right into that receiver. And eventually the low side pressure is going to get low enough that the system's going to be pumped down. Okay, so yes, in order to change a power head on an expansion valve, you can pump the system down. Correct, okay? Let's see what else we got. History repeats itself. That's exactly right, Bill. You know, you just have to be able to make some decisions and know when things are good, you know, or what you have to do to make things work correctly. So let's see what else. Thanasis, then why is your ohm meter beeping? It just depends on how the ohm meter's set up. Personally, if I'm checking continuity on my Fieldpiece SC660, I turn off the audible tone so that way it doesn't beep, and just use the ohm meter, you know. So it depends on how the setup of your meter is and what kind of how it works, basically. So what kind of guarantee do you give your repairs as far as time? Nathan Peterson. So we warranty our parts, whatever the manufacturer that we purchase the parts from warranties them. Typically that's 1 year for the most part, unless you're dealing with like Hoshizaki circuit boards or something like that. So for the most part, we honor whatever the manufacturer's warranty is for the part, and then we usually do 90 days on our labor. So, and that includes like our welding, you know, our braze joints and different things like that. But you know, it all depends, okay? Because I've been known to warranty something later than 90 days. You know, if I go in and be like, oh my gosh, that braze joint looks like crap, I'll take care of it, you know. I try to make my customers, you know, if I realize we did something wrong, we're going to try to make it right. But for the most part, on paper, it's 1 year parts, 90 days labor. So, all right, let's see. If I would have left the TXV, how long would it have worked? Well, the TXV, I did leave it. I haven't changed it yet. I just adjusted it. Now, how long would the compressor have lasted if I wouldn't have gotten that superheat up on that TXV? It's hard to say. It's a gamble. I mean, even still, after I make the repair, I'm going to make sure that the customer understands this system was running on extremely low superheat, and we could have compressor problems in the future. I have no idea the shape of the compressor. I did everything that I could to test the compressor, including inputting the numbers into the Copeland mobile app and doing a pump down test on it. You know, just checked everything that I could, make sure it wasn't overamping, make sure it wasn't getting too hot, you know, that kind of stuff. But I can't guarantee that that compressor is never going to have a problem when it was running with that low of superheat. So, and as far as how long it's going to be before that happens, I don't know. Oh, there you go. Corey Sayer, having trouble with the 3D scroll oil distribution with drop-in replacements for R22. You have a 3D scroll torn apart right now, but not a Copeland scroll. Do Copeland scrolls have oil pumps? Okay, so with the 3D scrolls, there's actually a service bulletin by Trane. And if you actually do some research online, you're going to find out that you should never, ever use a drop-in refrigerant on a 3D scroll compressor, especially if it has mineral oil in it, okay? The refrigerant manufacturers will tell you, oh yeah, our refrigerant, you know, drop-in replacement for R22 works great with mineral oil, but guess what? It doesn't work with the 3D scrolls. I have some history with the 3D scroll. If you guys don't know, 3D scroll is the giant green compressor. It's actually a Danfoss compressor, if I remember right. But I don't know if it's actually Danfoss. It looks very similar to a Danfoss compressor, but the 3D scroll is the compressor that Trane uses on their bigger package units. And you see them on the 15 tons and bigger, maybe some of the smaller units. But yeah, you do not want to use any of the drop-in replacement refrigerants on those. You only want to stick with the OEM refrigerant, especially when you're working with the 3D scrolls. I read something, I don't know if it's completely accurate, but it's something about the top. I could be talking out of my butt right now, but it's something about the top bearing on the compressor with the oil coming back. It lubricates the bearing, something like that. Okay, there's something funky about it, and you'll end up burning up the compressor. The motor will seize up because it doesn't have proper oil return or something like that coming back to it. But again, do some research, and there's actually a service bulletin. So if you look at most of the refrigerants, look up Trane 3D scroll drop-in refrigerants, and you'll see all kinds of posts about it on HVAC Talk, the message board, about why you shouldn't use drop-in refrigerants with the 3D scrolls. So yeah, be careful about, I mean, sometimes you can, but you just got to be careful about it. I've had some really bad luck. I went through 2 compressors myself doing that, and I ended up eating the cost of a 10-ton compressor. It wasn't fun. So what makes the Copeland scroll work better than the 3D scroll? I really don't have much to say about that, Corey. So yeah, it's Danfoss. I believe Danfoss makes that compressor, but Yeah, the 3D scroll. See, Zach's even saying it too. It's a reoccurring thing. A lot of people have said don't use it. Okay, how is it over there? How many % can a system leak during 1 year and still be okay? Stefan Boujor, I don't know how to pronounce your last name there, bud. But, okay, so here in the United States, the rules are if your system has, I think it's 50 pounds or less. I think someone can correct me in here. Maybe you can, Ralph. I think if it's 50 pounds or less, there's no rate at which you can't keep adding gas to a system. It's unethical that you don't fix the leak, but if it's over 50 pounds, then you have leak rates and different amounts that you have to, you can only leak so much per year before you have to fix it. But if it's under, I think it's 50 pounds, yeah. If it's under 50 pounds charge on the system, you don't have to actually technically fix it. You can just keep putting refrigerant in it. So, okay, so Ralph, you said you pump down a fractional horsepower compressor and it goes down to negative 20 but climbs back up to a positive 10 in less than a minute. Is the suction valve shot? Is it a reciprocating piston-driven compressor, Ralph? If that's the case, then yes, it does sound like you might have a problem there. Are you pumping it down on the suction service valve? I do have to say, you guys, people may have seen me do this before. It's an old school method of doing a suction service valve pump down test, okay? It's not necessarily the correct way to do it anymore. Copeland doesn't really recommend that you pump down a compressor. So the old school method on a semi-hermetic was we would front seat the suction service valve while the compressor was running. We would watch the compressor pull into a vacuum, and then we would turn the compressor off to see if the reed valve let gas bypass, okay? If it doesn't let gas bypass, then it would still hold in a vacuum on the suction side. But if it did start to rise and then went into a positive pressure, it indicated that we might have a bad suction reed valve. So we started to do that test on normal reciprocating hermetically sealed compressors. And in the beginning, it worked okay. But a lot of the newer compressors, they aren't meant to be pumped down anymore. So Copeland is actually, I don't know if there's a service bulletin about it, but they've basically said you don't want to do a pump down test to verify that a compressor is not working anymore. Now, I may do one, as part of a lot of diagnosis. Like I may check the amps, I may check the Copeland app, and I may try to pump it down. But you don't want to base your diagnosis simply off of it doesn't pump down anymore. Okay. Now, there's still some logic into, if you pump it down and it takes forever to get below zero. Yeah, there's something going on there. Okay. What I would highly suggest, especially if it's a Copeland compressor, is just simply use the Copeland app, Ralph. Look up the Copeland mobile app, input your numbers. It just asks for high side, low side pressure and your amp draw. And it's going to tell you, hey, something's not right. Okay. And it's going to tell you whether or not it gives you a percentage of failure. All right. Let's see what else. A bunch of things are going by here really quick. So, do I have a video explaining how to use specific field piece equipment I use and why you use the pieces you use? It would be a great sales tool for you if I don't, Bob. Yeah, I don't have a video explaining the field piece stuff. I will work on something with that, okay? I might be working with field piece soon with something too, so. All right, let's see what else I missed in here. Guys, if I missed your questions or something like that, don't just throw them back down in the bottom again too. So, okay. So another thing I want to cover, guys, is I'm reading these things. Nightbot is scaring you guys. You guys like the movie references that Nightbot is giving. So when you see Nightbot pop up there, tell me what movie that's from. That's actually from one of my favorite movie series. The franchise is the Silence of the Lambs franchise. Absolutely love those movies. Those things are awesome. My wife thinks they're the grossest things in the world, and I try to explain to my wife they're not gross. They're psychological. They just mess with your head. There's a few gross scenes, but love those movies. So, all right, let's see what else we got. And for those of you that are watching this that aren't paying attention to the chat, there's a whole thing going on in the chat. So if you guys can figure out how to look up the chat, do it, because then you'll see what's going on. There's a whole conversation beside the stream that goes on in the chat too. So, all right, so while I'm talking, this kind of led me into this. You guys got to remember something, and I've said this before. I honestly believe that there's something wrong in my head, okay? I do things really weird, kind of OCD. I'm sure there's some undiagnosed things going on in there. If I wasn't filming, I'm being dead truthful with you guys, I would talk to myself just the same as I do when I'm filming my videos. That's why I say it really doesn't take me any more time to film a video when people ask me, because it doesn't. I spend just as much time or I talk to myself the same. That's my thought process when I work is I'm working through things and I verbally say them out loud. Okay, I check this, I check that, I worked through. So, you know, sometimes the reason why I'm telling you that is sometimes I will express some opinions in my videos, and it's not so much that I want to bash that person. Okay, so I'm going to give you an example. In my last video, I was talking about how much I dislike the Emerson expansion valves and how much I dislike the Emerson solenoid valves. And someone had posted a funny comment and they said, let us count the ways. How many times have you said you don't like this valve or whatever, you know? And it kind of got me to think about it. Like, I really don't mean to be bashing Emerson. It's just, that's just my opinion and that's the way it came out. So I try to be as truthful as with you guys as possible without being vulgar or something like that, you know? And I mean, I honestly tell you the truth. Like, I really don't care for the Emerson valves. It is what it is. You know, nothing against them. Some people love them. I'm going to tell you right now, I know some of you guys that are watching from other countries, all you guys have is Danfoss components in your countries. I hate Danfoss valves, okay? Not that I'm ever going to work with them, so I just blew that sponsorship. But, you know, I don't like Danfoss expansion valves, solenoid valves, dryers. I just don't care for them, okay? Just not my preference. Nothing against them, just not my cup of tea, okay? So I prefer to use Sporlan components. That's why, you know, I work with Sporlan, but I'm not telling you this crap because I work with them. I'm super stoked that I get to work with Sporlan because I like their product, okay? So it's not just that I'm trying to be nice to Sporlan or anything like that. It's just, I just don't like those other components, okay? So I don't mean to be bashing other people or anything like that. To be honest with you, I kind of feel bad for saying what I said. But, you know, I'd rather not talk crap about anybody. So, you know, if I don't mention something, it probably means I don't like it. So, all right. Let's get, how often do I come across air handlers with adaptive airflow control based on customer count? In Germany, you have this type of system a lot. So we call this demand ventilation here in the United States, especially in Southern Cal or in California, because we have a lot of requirements. And so we have a safety code, I guess you can call it, that says that you have to have so much fresh air for the building per occupant. And the easiest way that we can measure this, which is still kind of a crude way of doing it, is by measuring the amount of CO2 in the building. So we have a CO2 sensor, and what it does is it measures the amount of CO2, and the theory is the more people, the higher the CO2, because we're breathing out CO2, right? So the more people, the higher the CO2. So then we bring in more outside air to ventilate the building, okay? If you don't do that, what the research has shown is that people start to you get that sick building syndrome where people get sleepy, offices, different things like that, because the CO2 goes too high and people are breathing that in and their bodies don't like it. So it starts to go into shutdown mode. So yes, we are having that. Now, I will not say that it's all the way across the United States, but I do know that everything that starts in California ends up in New York and then ends up floating around the rest of the world or rest of the United States as far as energy codes and requirements and safety crap. Unfortunately, a lot of people don't like the state of California because we bring in all this drama and crap into the industry, but it is what it is. There's nothing we can do about it. So yes, we do demand control ventilation is what we call it here in the United States. So, all right, guys, do I know about any training on refrigeration? We have lots of training classes around the United States at our local trade schools, Aldo. So I can probably lead you in a direction. You can probably send me an email to hvacrvideos@gmail.com. I would highly suggest for any of you that haven't already, go to the internet and search up rses.org. It is a regional training organization. We're on a national, actually we're on an international level because I know they have chapters in Canada too. But they are a training organization and they have lots of great training resources. If you're in the United States, I would also look up for online resources. It's About Q, which I believe is a California thing, and then also HVACR EDU. So it's hvacr.edu. They're an online training resource too. Other than that, if you're in the States, I'd look up your local community colleges, local trade schools, lots of information. I've mentioned it a million times before, but I would highly suggest for those of you that are interested in literature, that especially with the refrigeration, that you look up the book Commercial Refrigeration for Air Conditioning Technicians by Dick Wirz, W-I-R-Z. And it's a great refrigeration book that basically explains refrigeration to the technician that already knows how to work on air conditioning. So it's a great book. Highly suggest you check it out. in the show notes of this video, when it posts after this stream, there'll be links to all those books. So, or to that book and some other books too that I highly recommend. So, let's see what else. He needs a makeup bear in his office to make up for see what he puts out when he does. Yeah, exactly. I do need a makeup bear. That's all right though, because this apple juice is solving that problem. So, all right. Let's see what else I got on my list here. How often do I get to work on VFD-based systems, and what are the most used VFDs? Well, it depends on what manufacturer you're working with. So I work on a lot of Linux package units, which use a Mitsubishi VFD, I believe. I think it's a Mitsubishi. I think so. Allen Bradley's another name that comes up as far as VFDs, and then ABB, yeah, comes up. But yeah, I work on a few. So another energy code we have here in the United States, or actually in California, is basically that we have to have 2-speed systems if they're over 5 tons or over 2,000 CFMs, I believe. So we'll have VFD-driven indoor blower motors. So we do have to work with those. They're not completely variable speed. So basically, they just run at 2 speeds. So when first stage calls, it runs at 1 speed, and when second stage calls, it runs at full speed. So, but I do work on it a little bit. So, does a 3-phase motor draw high current when starting? Yeah, I mean, any motor is going to draw high current. It wouldn't draw as high as a single-phase motor. But I mean, the starting current is going to be the highest current of anything. When you put a VFD drive on it, you can keep it low because you can do a soft start. But yeah, it's going to draw a higher current for sure. Any motor is going to draw high current. So 3-phase is a lot easier to start because it doesn't have capacitors, so you don't have to add capacitors to it. So, all right, giggity giggity. All right, there you go. I like the Family Guy references. So, all right. So another question I had was about negative superheat. Negative superheat. So I actually showed it in one of my videos. My last video I was using the Fieldpiece app, and it showed negative superheat. So negative superheat's an impossible thing, guys, because what is the opposite of superheat? It's subcooling. So when you're using some of those apps, it's actually a problem with the app, is my understanding. So it's you don't have negative superheat. Okay, the app should have known better, and it just needs to be there's something. And I'll reach out to Fieldpiece and show it to them, and I'm sure they'll fix whatever it is. So, but yeah, it was just something in that video where it was just coming up with a negative superheat reading, but that was incorrect. It should have just showed 0 degrees superheat. All right, let's see what else. Yep, we got a lot of the HVAC overtime, guys. And you guys have a show coming up this Friday again, right? If you guys haven't already checked it out, check out the HVAC Shop Talk channel. Zach was in here earlier. He might still be in here. He has great content on there. He's streaming pretty much almost, it seems like, every day of the week. And then also he's brought on the HVAC Overtime show. A lot of the guys are in here right now too. So subscribe to the HVAC Shop Talk YouTube channel, and you guys can check out the HVAC Overtime show. It's on Fridays, guys. I don't know what the time is. You guys are feel free to post links in there, Justin, for them. So, all right. All right, let's see what else. It could also be your temp pro, because I don't know the question that's going there. So for those of you that don't know, there's a whole thing going on in the chat, like I mentioned before, and a lot of times the guys in the chat will help other guys too. So I just looked over there and noticed there was a conversation, and they're having a conversation in there about something else, so which is good. We're happy about that. How about the trade show in Pasadena, Aldo? I don't know what you're asking there, Aldo, but I typically go to the trade show when it's in Pasadena. So I will try to... let people know, and I'm also going to try as hard as I can. I'm going to try as hard as I can to go to the show in Florida this year too. What is it, the ASHRAE show? I believe. Is that what it is? You guys in the chat can remind me whatever I'm mistakenly saying right there. But yeah, there'll be the big trade show that's in. I think it's in Orlando this year, and I'm going to try to make that one. So I didn't make it last year when it was in Atlanta, I think. So. All right. Could I talk about working on EMS systems and what you're troubleshooting and what they handle? So Chris Cooley asked if I could talk about EMS systems. So EMS is the energy management systems. You're going to find those a lot in chain restaurants. I deal with them a little bit. 2 companies. Actually, I only deal with 1 company right now. Yeah, anyway, so I've got a couple restaurants that have it, but it's one particular company that's running their EMS service. So it's essentially just a monitoring service, okay? And they're paying attention to lighting, they're paying attention to air conditioning systems, they're monitoring temperatures. They can do all kinds of stuff with the EMS system. So What happens is let's say, for instance, I get a service call at the particular restaurant that has an energy management system. So when I arrive, I'll typically get a service call from the manager, but they'll say, hey, the EMS company called me and said I got an AC unit that's blowing high discharge air or something like that, or cold discharge air, depending on what season it is. So then we'll go out there, and essentially what it is the restaurant itself typically doesn't have control of the thermostats or the lighting controls. Okay, we don't deal anything with the lighting, so I'm just going to talk about the AC systems. So they do this for energy reasons, because they can have a single point maintaining their systems and making sure that they turn on, monitoring the systems. And a lot of the times the EMS companies will catch problems before the restaurant even realizes it. So when you have someone monitoring a system via a program on a computer or a person actually staring at numbers, they can pay attention and say, hey, the temperature between supply and return, they can set alarms on their computer, and it can say the system is calling, but my supply and return temperatures are equalized. There's a problem here before the restaurant even realizes it. Because if you guys don't realize this, a lot of the times an air conditioner could go down, and it could be hours or even days before the restaurant even realizes it's down. And by then they could be getting guest complaints. And the moment that a customer walks out of a restaurant because it's too hot in there, that's a lost sale for the restaurant. So the logic is that if they can solve those problems before the restaurant even realizes it or feels it, then they can save money. So they'll have an energy management company that uses all kinds of different controls. Again, they can do all kinds of stuff. You can have really cheesy, easy ones, basically, that are ran by internet-controlled thermostats, basically. And you can get those with a lot of the different manufacturers. There's some smarter internet-controlled thermostats like BayWeb, and then there's really fancy systems like Siemens and BACnet and, all kinds of crazy energy management systems. I don't deal with any of the big fancy ones. A lot of my restaurants just use like the BayWeb thermostats. Not really a fan of them, but they do have a user interface that you can get onto if you have access to their system. The only thing is it makes it difficult for, let's say, for instance, we got to do a preventative maintenance and we want to fire up all the AC systems. It's kind of a pain in the butt to have to call the energy management company and say, hey, can you turn on AC number 2? And then they say, well, why? Because I'm working on it. Okay. Can you do me a favor and turn it on for like 2 hours? Well, why 2 hours? And then you got to kind of go through that stuff. Whereas sometimes it's almost just as easy to jump the unit out, if the energy management company's not complaining. There's a lot of, you got to be careful because you don't want to ruin any of the energy management stats or anything like that. But yeah, oftentimes if I'm not getting a complaint from the energy management company and I'm doing a PM, I'll just go up and jump out the equipment. But you got to be very careful about jumping stuff out because you don't know what it's going to do to the EMS system. You don't want to mess any of their stuff up. You don't want to be blamed for it. So be very cautious about ever jumping anything out without talking to the right people. So, all right, AHR, there you go. That's what it's called. So, all right. Let's see what else. Okay, so another question I had was on a walk-in freezer, what is the target evaporator temperature on a walk-in freezer? So it depends really on what you're trying to maintain as far as box temperature goes. Okay, so in a walk-in freezer, for the most part, we're going to go for a 10-degree temperature differential, and that's the difference between the return air temp and the evaporator temperature. Okay, so with that being said, if we know our system is designed with a 10-degree TD, I can predict what my suction pressure should be. Because if I know what the box temperature is, then my evaporator temperature should theoretically be 10 degrees below that. This all kind of comes into play when the box is close to being down to temp. You do have to be careful because when it's under a heavy load, you could have a higher TD. If the expansion valve is flooding, it could change things. But once you get closer to box temp, you can certainly predict. So if I'm going for a negative 10 degree box temperature, that's a typical freezer temperature that stores ice cream is negative 10. Then I can assume that my evaporator temperature is going to be negative 20. So you can find that on a temperature pressure chart and follow that over to the corresponding suction pressure, and it can give you an idea what your suction pressure should be. That's kind of a rule of thumb. Okay. Everybody designs their equipment differently, so you got to be cautious about that. You don't want to just assume that's what it should be. But yeah, you can use that as a rule of thumb. Let's see what else we have. I'm making sure I'm not missing any questions in here. All right. Doesn't look like I'm missing too much. All right, so another thing that I want to cover, let me go through this list. I'm just kind of looking at this. I got that. All right, cool. Yep, okay, so I covered that. Another thing I want to point out, guys, I get emails from you guys all the time. And sometimes they're questions, sometimes they're homeowners, sometimes they're business owners. I don't mind helping out a homeowner now and then, or a restaurant owner. I typically am not going to steer them into fixing their own equipment. I highly suggest that you call a service technician if you are a restaurant owner or a homeowner. But I will answer questions to help them to understand things. Or sometimes I'll get a question from a homeowner, even though I don't do residential. They'll say, hey, I got a contractor out here and I just want to know if this guy's ripping me off. And I'm not going to say he's going to rip you off, but I will say, hey, you want to, they'll ask me the question and I'll kind of give them some advice. So I want to point something out. I have no problem answering your guys' questions, and I'm going to try to do this a little bit more on my streams, okay? I don't want to mention your guys' names unless you guys tell me you want me to mention your name, but whatever. So I'm not going to mention your names, but I'm typically going to read your questions aloud, and I'll try to answer them. And it's not to make fun of you guys or anything like that, and I'm going to point something out. So when you guys send me a question, what I really, really appreciate, and this goes with your service manager, with anybody, is give me context. Don't just ask me a question. My contractor says the superheat's low. What does that mean? Give me context. What is the service call? Why did you call them? What is he telling you? What is his diagnosis? All this different stuff, okay? So there's no stupid questions, but just give me context, give me your thought process. If you're a service tech that's asking me a question, give me your thought process. Tell me what you think is going on. Even if you think it's wrong, just tell me what you think, and then we can work on that, and I'll try to help you guys. I'm not promising that I'm going to answer everybody's questions, and I'm not promising that I'm going to pick every question to talk about it on the stream, but I will try to pick a few and answer them, okay? I'm going to pick the questions that I think can help people, whether it be, just you guys know what I mean. So let me read this one right here. So this person asked me some questions about my video on the walk-in freezer with too low of superheat. And they said, couple of questions, if you don't mind. That sight glass indicated moisture in the system. And this is their verbatim question, okay? It says, that sight glass indicated moisture in the system, probably due to leaks over the years and charging without purging and whatnot. Wouldn't I want to change out the dryer before adding any gas? Also, 404 is a blended refrigerant. Would you want to recover that gas and then add fresh 404 to ensure we didn't fractionize too much? Or was the process to charge in some gas first and see if that cleared up the temperature issue, then put in for a bid to replace the dryer valve nut? Okay, so let's start this question at the beginning, and this is a good question. So first off, a sight glass doesn't indicate moisture per se, okay? There is a moisture indicator in the sight glass, but we weren't seeing that in my sight glass, okay? And I'd be very cautious about using the moisture indicators in a sight glass. Typically what we're looking for in a sight glass is bubbles, okay? There is a little piece of paper that reacts to moisture in the system. It'll change colors, different things. But you always want to follow that up with a moisture test or an acid test, okay? So don't just trust what's in the sight glass. But I'm guessing off of the question that he asked me that he meant that the bubbles in the sight glass, that wasn't moisture, that was just indicating that we were potentially low on charge. When in fact, I found out that it wasn't low on charge in that system. It was just the expansion valve acting erratically, okay? There was a restriction in the expansion valve and it was causing some funky things to happen in the system. And the reason why I say that is because I added like 6 ounces of gas and it cleared it up. I highly doubt my system was low on charge. It was probably just something funky with the glass, okay, or with the valve. The next thing inside of his thing, or in his question, he was saying, wouldn't I want to change out that dryer before adding any gas? And no, there's no reason to change a dryer before adding refrigerant to the system, okay? Thank you, Jeremy. I really appreciate it. The only reason why we would want to change a dryer is if it had restriction in it, if it was the system had contaminants, or if we open the system to atmosphere. That's when we're going to change a dryer, okay? We're not going to change a dryer just simply because it's low on charge, all right? The next part of that question that he had was 404 is a blended refrigerant. Would I want to recover the gas, then add fresh 404 to ensure we didn't fractionate? 404 is a blended refrigerant, but the fractionation rate is so extremely low, you really don't have to worry about it too much, okay? I'm going to be honest with you. I don't think I've ever ran into fractionated 404. Even when you have a system that was extremely low on gas and you topped off the charge. I'm not saying it'll never happen, but I've never had a problem with it. Same thing with 410A too. 410A has a very low fractionation rate. So you can add refrigerant, okay? That's just my experience. I'm not saying that you'll never run into those problems, okay? So this was a good question, guys, and this is the kind of questions that I like to get from you guys. I'm not worried that he was incorrect in some of the things, and I'm not trying to be rude or anything. This was a great question, though, because he gave me his thought process. He gave me what he thought was going on, and then I was able to answer it accordingly. So if you guys do have questions and you send them to me, put them in a format like that. Tell me your thought process. Tell me what you think is going on there, okay? Yes, it is very difficult to fractionate a refrigerant. Guys, that is Ralph. He works for Honeywell, and he's always regularly in here to answer questions about Honeywell refrigerants. If you guys have any questions, don't hesitate to send Ralph an email, and I will actually give you guys his email address right now. I usually have it set up, but I'll look it up real quick. So let me look up. I have him right here, and let me copy this, and I will put it into the chat. If any of you guys have questions about refrigerants, Ralph is always willing to answer them. So, and that is a good point too, that you can top off your refrigerant in the liquid state. That is very important, especially when you're working with blended refrigerants, is that you do want to make sure that you are in the liquid state when you're topping off the refrigerant. That's blended refrigerants, okay? R22 is not a blend. R134A is not a blend. Everything else pretty much that we're going to work with these days is pretty much going to be a blend. So be cautious. But yeah, I charge liquid refrigerant almost everything I do. It's just a force of habit, even when I'm working with R22. So, all right. Okay, so Fluke196, he likes my Sporlan pint glasses. I'll bring this up again right now. Sporlan has a promotion going on right now. Sporlan 85. It's to celebrate their 85th anniversary right now. This is apple juice in this thing, by the way. If you take a picture of any old Sporlan memorabilia, if you're in a supply house and they have an old Sporlan poster, an old Sporlan valve, if you're out in the field and you see a Sporlan valve, the promotion is supposed to be the older stuff, okay? Take a picture of it, post it on Twitter, post it on Facebook with the hashtag, so that's the number sign, Sporlan85, and you'll be entered into a drawing. Sporlan pays attention to the hashtags and they track them, so they know when you post the pictures, and you'll be entered into a drawing, and they're going to be giving these away. I believe they have 85 of these glasses they're going to be giving away, minus the 3 they sent me. So pretty cool little glasses, pretty nice, pretty heavy duty, and it's super easy. You don't got to do anything. Just take a picture and post it on Facebook or Twitter. So go for it. All right, Isaiah, I see that you said you have a question. Go ahead and post it in here, and I'll try to get to it. The AC is usually set on high or medium at the lowest, and heat and low. Oh, okay, so Justin, you're answering that question for him. Okay. So Isaiah, go ahead and post your question, bud. HVACR North, that would be a lot of scotch. If I was drinking, that glass was full. If I was drinking that much scotch, I really think I have a problem. So, plus, I'm sorry, guys, I'm going to say this. I'm going to piss off half of you guys, but scotch tastes like cigarette butt water. So, no offense. I'm more of a bourbon guy. So, on a glycol beer cooler, old compressor was R12 and you use 409. Pressure should be same with R134A, right? It's similar to R134A. You know, whenever I'm working with any of the blends and it was an R12 replacement, it was always easy for me to use because I was very comfortable with R134A pressures. So in that situation, depending on if your beer cooler has a capillary tube or a TXV, I would charge via superheater subcooling. If it has a receiver, it's easy, clear the sight glass, but you got to be very careful when you're using the R12 drop-ins and clearing sight glasses. Even though if it has an expansion valve, even though it's supposed to have a clear sight glass, a lot of times the system capacity can't hold that much refrigerant, so you got to be very careful about charging that stuff like that. But yeah, I would charge by superheater subcooling depending on what. Feel free to send me an email, and that's Tito209. Dude, me and you converse all the time, but I do not know your name, so I'm sure you've told me, but I forget. But send me an email and we can talk more about it. So, all right, let's see what else. Let's see what else I'm missing here. I'm Isaiah. I haven't seen your question come through yet, bud. So make sure you put it in caps lock here, and I'll try to get to it. Okay. Okay. Next question I have was from another person, and their question was, and I'm reading their question verbatim. Okay. It says, I understand the industry likes to see compressor superheat of 10 plus or minus a couple of degrees. The system superheat is measured from the suction line 8 inches or so before the suction input of the compressor. What system superheat would you like to see as a minimum? Okay, so let's kind of correct a few things with your question there first, okay? Let's see, compressor superheat is typically 25 to 35 degrees minimum, okay? Or maximum, typically, okay? Copeland in the recent years, and that's compressor superheat. I think you were referring to evaporator superheat when you said 10 degrees. And it really depends on what you're working on. So and this is a rule of thumb, this is not 100% for everything, but if you're working on a walk-in freezer, you're typically going to be somewhere like 6 to 8 degrees, for evaporator superheat. And if you're working on a walk-in cooler, 8 to 10 degrees. Sometimes up to 12, okay? But again, it depends on what the TD of your evaporator is, okay? If you're trying to maintain a produce cooler or something like that where you have high humidity, you might run a different TD. So different things matter. You have to know how your system was designed. So evaporator superheat is typically lower. Evaporator superheat is measured on the suction line coming out of the evaporator. Then you typically use the superheat port, which is on the suction header of the evaporator. And then you take a suction line temperature right by where the sensing bulb is. And that's how you get your evaporator superheat. Now, compressor superheat is measured, and that's system superheat or total superheat. That's on the roof, okay? That's measured, 8 to 10 inches from the suction line before it enters the compressor. Now, something very important you have to understand. If you don't have an insulated suction line going all the way up to your roof, you're going to have extremely high compressor superheat, which is going to cause problems. Insulation is actually very important on your refrigerant line, so you got to make sure you're properly insulated, okay? So another thing, though, too, is in the past years and classes that I've taken with Copeland, and I've done some reading about this, too, Copeland always recommends 25 to 30 degrees, 35 degrees maximum evaporator superheat or compressor superheat. But actually, they tell you as long as you have some superheat, okay? They're not necessarily saying they don't want, they typically don't want to see it above 35, but it doesn't have to be 25 to 35, just so long as you're not slugging refrigerant back to your compressor and you have some cooling coming back. You have to remember that we often will use that compressor superheat to cool the compressor. A lot of our compressors are suction gas cooled, so that's why it's important, especially when we're dealing with these scroll compressors. A lot of times they're suction gas cooled, so we got to keep that superheat down. You don't want it to be too low, but you want to keep it down so that way we can cool the compressor and it doesn't overheat. All right, let's see what else we got. Okay, and okay, so here's another question, and I'm going to use this person as an example, and I'm not bashing you if you're in here, okay? This sounds like a homeowner that sent me this question, and I just want to use this as an example. So it says, I have a question. It says, I have a heat pump that is not keeping my house cool. I had someone come out, and I have low superheat, and I am flooding the A coil. I have the correct charge, a clear sight glass, and a clean coils. The condenser is discharging warm air. The tech could not figure out, and they're asking me if I have any recommendations. Okay, so there's a lot of red flags there. First off, I have said that I like a sight glass on a air conditioning system, but I don't like the fact that the person says they have a clear sight glass, because that doesn't mean a whole lot to me, all right? I did just mention on the last one that I do like a sight glass because it's an indication of a gross undercharge, but we do not use a sight glass to indicate proper refrigerant charge on a split system air conditioner, okay, unless it's a built-up system that has a receiver, okay? We will use a sight glass as like a preventative maintenance measure to tell us when we're extremely low, but you got to be cautious. So that question is kind of a red flag, and I'm missing a lot of context there. So this person is asking me just for some advice, and my advice to this person is that you get another service technician or service company to come out and give you a better diagnosis, okay? Because what I'm being told in that email, that's not enough information, and if that's what the service tech told you, they're not giving you enough information either. So I'd suggest getting another quote from another service company to give you a proper diagnosis, okay? Low superheat can mean all kinds of stuff. It can mean bad airflow. It could be overcharged. It could be a dirty coil, anything, okay? So I'd highly suggest you have another service company come out and properly check that system out. So let's see what else we got. Okay, can I explain why the removal of a receiver is important on a capillary tube system? So that's a good question, Kyle. So here's the thing. there's a capillary tube system is a fixed orifice metering device, okay? And we often say that receivers don't belong on capillary tube systems. And there's truth in that. But actually, we can make a system work that has a receiver with a cap tube. But typically, you're going to have to overcharge that system. It's kind of a waste, okay? A receiver is a storage vessel for the extra refrigerant that the expansion valve needs when it opens and closes, okay? So if the expansion valve isn't feeding very much refrigerant, you're going to have a lot of refrigerant stored in that liquid line receiver. But if it's using a lot of that refrigerant, it's going to get a little bit lower. So when you have a capillary tube system, you're basically going to charge it via superheat, and it needs that certain amount of pressure drop across that capillary tube all the time. That pressure drop really doesn't change much. So that means that you have to have so much volume of refrigerant on one side of the cap tube at all times, maintaining the pressure in the system so that way it can feed the refrigerant through and boil off in the evaporator properly. So a receiver is kind of a waste on a capillary tube system. If you have a receiver, you typically are going to have way too much refrigerant in there, okay? So I wouldn't suggest keeping a receiver in a system that has a capillary tube, okay? Just kind of something you don't need in there. It's just a waste. So let's see what else. I'm seeing what I'm missing in here, guys. Yeah, great questions, guys. I'm trying to get to them all. Make sure you try to put them in caps lock, and I'll try to answer them as best as possible, guys. So let's see. Yep, okay, so Andrew Hicks had a HTPG evaporator the other day that had no taps, had to do old school TD to adjust the TXVs. It was kind of fun. And so what we would do potentially, if we had no taps, there's a couple different ways you can go about it. What you can do is you can put your service suction pressure gauge up on the roof, assuming that you don't have a giant pressure drop, okay? But the fear is that you've got a really long line set that has a lot of P-traps. It's got a big pressure drop. It's got a restriction in it, all kinds of problems, right? And the suction pressure on the roof might not be the true suction pressure down at the evaporator. On a normal system, I would say that the pressure difference between the evaporator and the condenser might be 1 to 2 psi. Not that big of a deal. So what you could do if you didn't have any big pressure drops is you can take your suction pressure on the roof, take your suction line temperature downstairs, and you can do the math and find out what your evaporator superheat is. Then there's some other methods too that people have used about charging. There's some old school methods. Charging off of air temperatures, supply and return coming out of the evaporator. And that's another thing I want to cover too. That can be kind of hard if you don't know what you're doing, okay? Oftentimes on a evaporator for a walk-in cooler, you can't really do like a TD, like a delta T across the evaporator. It's not going to be a consistent number like it would be on an air conditioning system, because at different points in the evaporator, you're going to have colder temperatures, you're going to have warmer temperatures. On the top of the evaporator, it might be a little bit colder. On the bottom, it might be warmer, different things. So you're very, very sensitive as to where you're taking that temperature. So, but yeah, there is a lot of the old evaporators that didn't have a superheat port on them. They expected you to install them when you did the install, and a lot of them didn't get installed with them. Another point that I want to make is adjusting on expansion valves. So I did mention it a little bit in the previous video that I had about you really shouldn't be adjusting an expansion valve. And most expansion valves, past the point of install, they really shouldn't need to be adjusted. And if you're having to adjust on them, it might be an indication of a problem, whether the expansion valve's strainer's plugged up, or there's something stuck in the valve, or you have a power head going bad on the valve. In my opinion, in my experience, one of the more common problems we have with expansion valves is power head failures. And oftentimes it's because the sensing capillary tube rubs up against something and it loses its pressure charge, or slowly loses its pressure charge, and it starts to fail, okay? So if you're having an expansion valve, for instance, the system that I had on my last video, that you're having to adjust, I'm leaning towards there's something going on here and we need to figure out what it is, because you shouldn't have to be adjusting on an expansion valve for the most part, okay? Expansion valves are pretty durable unless there's some kind of foreign contaminant in the system. There's really not a lot that can go wrong in a valve. I mean, let me grab one real quick. So I had cut up a valve. I don't know how well this is going to come across to the camera, but let me point this out right here. So I had cut a valve. I did a cutaway on it. And there's really not a whole lot going on inside that valve, okay? There's a spring, there's a diaphragm, There's a power head, and there's 2 pins that push that spring up and down, okay? And there's a pin on the top of this spring. It's going to be really hard for the camera to see. I can actually pull this out of the way, and you can see a little bit better right there. There's a little needle, and that needle opens and closes via the superheat spring. So there's really not a lot of parts that can fail inside this valve per se. Besides the sensing element, the power head is what can fail the most, okay? The power head rubs up against something, and it becomes a problem. So I have Sporlin sending me out a bunch of other components that I'm going to try to cut up for you guys, and then we can start to make some videos on them and show them. So hopefully that'll explain a few things with them. So let me see what else we got in here. Let me see. What is Robbie G's question? I haven't seen it, guys. Where's Robbie G's question? I see someone saying Robbie G has a question. Robbie G, worked on a Federal 134A deli cooler today that had a TXV and no receiver. Tech support was surprised, and so was I. Is that common? Well, with newer, depending on the manufacturer, I have actually seen manufacturers design systems without receivers. Oftentimes, there'll be enough storage capacity, the condenser will be oversized. So, for instance, Charleston is a very big refrigerator manufacturer, and they will often install systems without liquid line receivers, but still have expansion valves. Same thing in like residential package units, will have an expansion valve too, but the condenser is usually a little oversized, so there's room for that extra refrigerant to be stored. So it's not off, it's not the end of the world, but if tech support said that it shouldn't have had one, then more than likely that system was a capillary tube system before, and someone converted it to an expansion valve. In that case, I really wouldn't lean on that one. So I would find out what was supposed to be properly installed in that system, and then go from there. How reliable is the capacity measurement on the field piece probes, Chris? Okay, so excuse me. I would say the capacity measurement on the field piece probes is probably pretty accurate, but the biggest variable in the capacity measurement, because it's just physics figuring out the capacity of the system, right? It's the enthalpy change, I believe. I don't remember what the actual formula is, but I believe it has to do with the enthalpy change, and it's the airflow, the CFMs, and the amount of enthalpy change, I think is what the formula is. I'd have to go back to my old school days, but the variable in the capacity is your airflow. How do you know that your airflow is accurate? That's the hard one. See, the field piece measurement, the field piece app doesn't estimate your airflow. If you use Measure Quick, they use a backwards way to estimate the airflow that's actually pretty darn accurate. But assuming that you have 400 CFMs per ton, but you don't know that, because when you input those numbers into the field piece app, it's just a guess, right? Unless you're actually measuring the airflow. So the variable in the field piece capacity measurement is the airflow. You have to make sure you're getting the proper airflow. If you know you're inputting the exact airflow into that system, the capacity measurement is going to be spot on. But if you're not inputting the right airflow, and you can't just assume the airflow, you can't check the airflow off of the static pressure. You have to measure the airflow. But it was 15 years old. Oh, okay, Robbie G, that's interesting. If it was factory, yeah, then that's fine. I mean, it happens. Those older systems, they did that. They ran a TXV without it. I believe they were typically externally equalized TXVs. They might have had, I know the Charlestons were always externally equalized TXVs. So can a walk-in freezer perform as a walk-in cooler for a limited amount of time, and what will happen to the system? James Rod, there'd be a lot of things that you need to change in that walk-in freezer system. The defrost strategy, you're going to have to rewire the coil. The evaporator fan motors need to stay running when it's in defrost. The limit switches wouldn't work that are in there for defrost. And in long-term effects, the compressor could be affected badly too, because the suction gas coming back, it's requiring that lower suction gas to the compressor. So there's some things that could go wrong in converting the system. So I would highly suggest it can be fixed, but it's not something you want to just turn it warmer. It's not going to work right. So is there anything I hate or dislike doing when it comes to repairing HVACR? Excuse me. So something that I dislike in working with HVACR, the traffic. I dislike the traffic. I drive in traffic every single day. I mean, it's something I'm used to, but I dislike the traffic for sure, especially in Southern California. you know, I mean, of course, nobody likes working in 115 degree outside air temperature when you're trying to change a compressor or something like that. That's always sucks, you know, when it's really hot, but the hot time is the busy time, so you just learn to deal with it. Other than that, I mean, things that I hate, there's not really a whole lot. I'm not a fan of changing door heaters on walk-in freezers. Those ones I really don't care for. They're so meticulous, and you have to do everything perfect for them to last right. But yeah, I really don't have much to say that I hate about HVAC. I like it. Okay, so let's see what else. What other questions am I missing, guys? Is there anything I want to make sure I get to your guys' questions here? Let's see. Am I going to make a new channel where you just cut refrigeration components open? I don't know that I'll make a channel. That'd be interesting, huh? I could be like the What's Inside family. Lincoln and his dad. I can't think of his dad's name right now. If you guys watch YouTube, there's the What's Inside family where they just cut stuff open. I might do it a little bit more on my channel. Guys, I think I showed you guys on the last stream, but I'll show you the other parts I cut open. So the other parts that I cut open was a liquid line solenoid valve. That's really basic in its operation. Sorry, I can't seem to get that straight versus the camera. But liquid line solenoid valve just has a diaphragm that opens and closes. That's it. Really cool little one. This was the one that I've worked with these before, but a head pressure control valve. That was a really cool one to cut open. There's really nothing to them. It's just a spring and a diaphragm that opens and closes. And then liquid line filter dryer. Not much to that. This is a Sporlan liquid line filter dryer. Open. There's your core. There's the inside of the dryer. That's pretty much it. There's a mesh screen. Oh, just you can't see that. There's a mesh screen there and a little thing. Those are the parts that I cut open so far, but I got Sporlan sending me some other parts so we can cut them open and maybe do some more cool stuff with them. So hopefully we'll get that going. Let's see what else. Rule of thumb for refrigeration subcooling. Well, in refrigeration, we honestly don't pay too much attention to subcooling because a lot of times we have a liquid line receiver. So if we have a liquid line receiver, we're going to ignore subcooling for the most part. You want to have some subcooling, but we're not going to use that as a charging metric. So we're going to typically use a sight glass as a charging metric to make sure that we have a solid column of liquid go into our expansion valve. And then if we require winter charge for a head pressure control valve, we would add extra refrigerant. So there is no rule of thumb per se when you're working on refrigeration and subcooling. So yeah, you can tell I hate work a lot, guys. So amen to the traffic. Let's see. You think most people could agree the worst part about their trade are the ruthless on-call for some of us techs. So what we do at my company, I'm not praising my company. We have our problems too. But what we do for our on-call, and it's kind of different. So for years, we did an on-call situation where you're on call for a week at a time, okay? Monday to, Sunday night, basically. And you had a full week on call. And what we started to notice was, or after the years, it was like, I'm exhausted. I worked an entire week of normal work, and then you had crazy on-call. So we went to a rotating on-call. I'd have to show you guys in the calendar. I've described this before, but we have a 5-week rotation at our company, okay? So I have 2 other service techs that take the on-call. I take 3 calls. What we do is we each get 1 day during the week, okay? And then someone gets Friday, Saturday, Sunday, and then we rotate every week. So you never get every Monday. You never get every Tuesday. Every week you move up the list until you're Friday, Saturday, Sunday, and then you rotate around. So when you're on call Friday, Saturday, and Sunday, you're automatically off call until next Thursday. And then you work your way backwards through the week. So we do that, and we find that a pretty cool rotation. So everybody has 1 day during the week, okay? And then one person is going to get the 3 days on the weekend. And it seems to work out really well for us. So I got that from, I don't remember who, someone in one of the Facebook groups many years ago recommended that. And we found that to be a great method of an on-call schedule, and it works really well for us. So, yeah, I will put the cutaways on my back wall. So once I use them, I show them to too many people. And yes, I will cut open a compressor too. So let's see what else. Rule of thumb. Okay, so I answered that. Got to jump off. Send any refrigerant questions my way. Great show. Oh, right on. That's Ralph. Thanks again, Ralph, for coming in here. So let's see what else. Haven't seen wasps out here in a long time. Knock it off. I don't know. I don't see them very much anymore. So what other questions we have, guys? Yeah, it is a pretty complicated thing, but when you put it on a calendar, it really makes sense. So it doesn't get too confusing when you put it on a calendar. It just totally, it's actually, you don't even have to think about it when you're doing the on-call schedule because there's a pattern to the calendar and it's just really easy to follow to figure out the on-call schedule. So how do I bring up compressors and heavy motors on the roof to through the hatch? So if it's anything probably 70 pounds or bigger, we're either going to use a mechanical lift. I have like a mechanical lift. I'll have to show a picture of it sometime where I can lift things up 26 foot on the roof, or I will use a crane if it's too big. But for the most part, if it's 70 pounds, sometimes if it's 100 pounds, I might get two guys to grab a rope on each side and pull it up the hatch or pull it up the side of the building. But I don't want to drag things up the side of the building or anything like that. You don't want to mess up the paint. But for the most part, we're just going to lift everything up. I don't work on big industrial stuff, so I don't have to lift stuff that's too heavy. And if I'm going to do a condensing unit or something, we'll use a crane. So. Ever work out of a utility truck? Yes, I did. I had a utility truck for about 6 or 7 years. It was a Chevy 2500 on an 8-foot bed, big old giant heavy duty thing. It was nice, but I decided I wanted to go back to a van just for a change. There's good things and bad things to a utility truck. It's nice because everything has its organized place, but then a lot of times the back of the bed gets to be a mess. The refrigerants, you have to climb through the back of the bed to get to the refrigerants unless you have one of those fancy racks up on the top. But I liked my truck. It was nice. But for now, we're just out of vans. So. All right. Yeah, exactly. The best part is guys can plan day off and vacations very far ahead with that on-call setup. That's correct. That's the cool thing about it. And we're pretty flexible, guys. If I have something going on, I'll ask my guys way ahead of time, will you cover this weekend for me? The reason why I like that on-call schedule is because you don't feel like you worked an entire week of 40 hours plus another 25, 30 hours on top of that. If we have a busy weekend, you had a full 40-hour week and you had, a 20-hour or a 10-hour weekend or something. So whatever it is. Okay, so does the firing or quitting ratios on a company say something about a company? Yes and no. I mean, nowadays in my opinion, with the short workforce, you have a shorter retention rate. People tend to leave the company a lot more nowadays because the next company is offering them a heck of a lot more money than you were paying that technician. And a lot of times people jump ship really quick nowadays. In the past, that was definitely a good metric. If someone got like for instance, I get resumes all the time. I'm looking over someone's resume as we speak. And, they in the past 4 years, they've worked for 5 companies. And it's like, wow, that's a lot of companies. But nowadays with the techs and stuff, that's actually not that bad. With the younger generation, they say that it's normal for them to switch companies. It's less normal for them to stay at a company for a very long period of time anymore. So things are changing, and you kind of have to look at things a little bit differently. Same thing with the company too. If the company goes through a lot of technicians, there could be a problem there. That, or they're just a very strict company. I think I'm pretty strict about the way that I do things. You guys see the way that I work. That's how I want technicians to work too. I'm not saying every one of my guys works the exact same way as I do, but they understand that I want them to strive for excellence and always try to do things properly. So, it is what it is. Am I union? Also, what is the pay for an HVAC tech in Socal? So no, I'm not union. I got nothing against unions. Unions just aren't strong here in Southern California. We do have a small union workforce, but nothing as big as the private force. As far as pay rates for refrigeration and HVAC tech working in restaurants right now, anywhere from $28 to $35 an hour for a standard technician. If you're crazy smart and can really handle your own load, the sky's the limit. You can basically, say your pay, and there'll be someone that'll pay it to you, whether or not they keep you as busy. There's a lot of factors that go into that, but all right. So you're thinking about NATE air-to-air certification. Is it useful or just another way for companies to make money? Okay. So here's my spiel on NATE. I am NATE certified. Do I think that being NATE certified makes me a better person? Yes. And the reason why I say that is because it made me pass a test. Does NATE make me better than you? No, it doesn't. Okay, it doesn't make me better than the next technician, but what NATE does do is NATE makes you continue your education. So I do understand people's complaints about NATE and that they say that it's just a money grab, and I can kind of understand that. It is very interesting that I have to pay money every 3 years no matter what now with NATE. But the cool thing about NATE is they require me to continue my education. So I have to have continuing education hours to maintain my NATE certification on top of paying a fee. So that means that I have to go to schooling. I can't just, not take classes and not learn. We have to continue to learn. So I do agree in continuing education, NATE certification, ESCO certification, RSES certification. But is it going to make you better than the next technician? Not necessarily, no. Okay, it's just going to make sure that you maintain and continue to strive for excellence. That's what NATE or any of those other certifications is going to do for you. So, yeah, guys, I see there's stuff going on in here, but if you put questions in caps, I'll get you answers, okay? So try to put your questions in caps, guys. Let's see what else. Let me see. If I ever move down south from San Fran, can you apply? Oh, sure. Yeah, man. Send me an email, dude. But Southern California, it's definitely going to be cheaper than San Francisco, but it is pretty expensive to live down here. But, it's pretty crazy. You guys that are in the Midwest and stuff like that would probably crap your pants when you find out, that a 5-bedroom house on a 6,000 square foot lot is going to cost about $700,000 here in the area that I live in. So that's pretty crazy when you think about what you can get in the Midwest states and some of the, up north and stuff like that. So, but San Francisco, that's nuts. You could get a 3-bedroom apartment on the island for freaking, $4,000 a month, $5,000 a month. All right, let's see what else. Yeah, I would definitely cut open some failed compressors. I've got a bunch of them sitting on the side of my shop. I've got some working compressors too that failed for refrigerant leaks on the bodies and different things like that. So I can definitely make them work. So, all right, so right on. And guys, for those of you that haven't already, my buddy Bill in here, he's Curious HVAC guy. He's got a great YouTube channel too, so definitely check out his channel. He's got some good stuff on there. There's a lot of guys in here that have good channels going on. So you interview for a service manager position, Nicholas. Just remember, just like I tell the young guys that are interviewing for their first time with another company, is you're interviewing that company just as much as you, man. And don't just make sure you get a clear explanation. I'm sure you know this, dude, because if you're going for a service manager position, you're going for a higher up. So this, man. Make sure that they're not going to overwork you and expect you to run the company all by yourself. So can you use a 4-ton condenser for a 5-ton air handler? That's not recommended, Case Services LLC, unless you're trying to achieve some crazy weird system there. It's highly recommended that you don't use a 4-ton with a 5-ton air handler unless you're trying to do something funky with the humidity or something like that. Crankcase pressure regulator. Oh, crankcase pressure and how it affects oil distribution, Corey. I'm going to have to think about that one, Corey. I honestly don't know the answer to that one right off the top of my head, so I'll definitely put that on my list of stuff that I want to talk about on one of my streams or something like that. Let's see what else. All right, guys. It made you feel all warm and fuzzy there, Bill? All right, cool. No worries, man. Let me see something here real quick. Let me look up, and I'll actually post a link here. Control-C. And post this in here. This is Bill's channel, Curious HVAC guy. You guys check that channel out. It's a pretty cool channel. He does some good stuff on there. He's releasing more videos than I am on a weekly basis. So, quick connects seem pricey, and that's great that you bring that up, Weaver Maintenance. Quick connects seem pricey for a simple connection. Adam, dude, thank you. There you go, man. I really appreciate that. You didn't have to do that just to post your thing. You could post that in there anytime, Adam. Let's see. I got distracted there for a sec. Okay, Weaver Maintenance, quick connects. What purpose do they serve? So a quick connect is for a pre-charge system. So we use them oftentimes. I'm not a fan of them, but they use them oftentimes on coal pack equipment. because it's just supposedly going to save them on installation time. There's no evacuation of the system. There's no charging of the system. Theoretically, the system is properly charged as it is. You just measure superheat and adjust the expansion valve on startup. So essentially, it's a one-time connection. Once you connect it, you got to make sure that you lubricate the threads properly and tighten down the nut to the proper torque setting. And once you do that, it pierces a little mechanism inside there and allows the refrigerant to flow from the line set into the condensing unit or into the evaporator. So the whole purpose of a quick connect is just a pre-charged system that you don't have to do much with. I'm not a fan of quick connects. In my opinion, they leak, they get in the way, they're hard to insulate, they're a pain in the butt. But you have to deal with them if you do any kind of ice machine work. It's a normal thing. So, all right, let's see what else. Do I work on a lot of BAS systems? Not a lot, actually. I have some energy management systems, but nothing too crazy. So, do I like plumbing? Sure, I like plumbing. I don't like working with shit, though. So, if my employer is not continuing my education, should you look for another job? Not necessarily, but I think that that's kind of an open question. I don't know all the details of your situation, bud. So if you think that you should be looking for a job, then maybe you need to be looking for a job. But I'd say to be cautious about assuming the grass is always greener on the other side, because it's not. Sometimes it's crappier on the other side. So, things that I offer my employees, if they want to go to a training class, then I don't mind sending them to a training class. But I'm not going to send them to a $5,000 training class if I don't think it's going to benefit them and benefit me and make us money as a company. But do I want to send them to an ice machine training class? Sure. That's like a regional one-day class or something like that. For the right technician, I'd consider sending them to it. It just depends. So, all right, let's see what else. Will I make a video on economizer settings and sensor operations? Definitely. As things start to cool down, we'll make a video on an economizer setting and definitely talk about them a little bit more. Especially nowadays, now that economizers have gotten so much simpler, when you talk about like the Honeywell Jade controls, so much easier than the old like 7200, controller for the Honeywell. Yeah, those things were a pain in the butt. So, all right, gentlemen, I think I'm kind of running out of things to talk about. So I think we're going to, it's fertilized with bullshit. I like that, John McMaster. That is a great comment right there, dude. I'm going to remember that one, dude. That is an epic comment. I wish I could pin that right now. Haha, the grass is greener because it's fertilized with bullshit. That is, you get comment of the night, John. So, right on. But yeah, I'm going to go ahead and wrap this up, gentlemen. I've never been to a $5,000 class either, Superior. I was using that as an over-exaggeration. So, but yeah, I'm going to go ahead and wrap this up. And gentlemen, I really appreciate you coming in here, and ladies, if you're in here. Please send me emails if you guys have questions. And we will... am I official field piece beta tester? Yes, I am, Zach. Now, just because I'm a beta tester for field piece doesn't mean that I test every single item that field piece comes out with, because they'll send some items to some beta testers and send some other items to other beta testers. So I'm not an official, I don't test every item. But I have tested older products in the past, and I am still on their beta tester list, and I'm in their ultra whatever cool kids group, beta testers and stuff. So yes, I am. But all right, going to go ahead and wrap this up. Gentlemen, I will catch you guys on the next one.